Welcome to SRA 221. In this video, we will continue our discussion on authentication, specifically on password authentication. We will now consider some attacks that can be launched against the password-based authentication mechanisms. Specifically, what we want to identify is the class of most common forms of attacks that these types of authentication mechanisms might be subjected to. We can identify two classes of these attacks, which are client-based attacks and server-based attacks. Client-based attacks aim at guessing the user-based password rather than the password stored on the server. So in the case of client-based attacks, there are a few things that an attacker can try to do, one being a brute force attack or a dictionary attack. Brute force attacks are targeted against the user and will generate as many passwords as possible, given the alphabet that are being used to create passwords or dictionary attacks. With dictionary attacks, the attacker relies on a dictionary of commonly used passwords. These passwords are ones that will be used for trying to attack the system. A dictionary attack is actually highly effective because many users use common words in their passwords, such as the name of family members or pets. As with anything that is vulnerable, there are always countermeasures. The most important countermeasure is having a strong password. With a dictionary attack, it would be highly unlikely to be successful if the user has a combination of capital letters, lowercase letters, symbols, and numbers in their password. This is because standard words in a dictionary do not have symbols and numbers. An additional countermeasure would be to use your password and a token. A token is generally synced between a piece of hardware that displays the token number along with the server and the mechanism that drives it. Essentially, the token can change depending on what the server settings are set to. If the password and token match, then the user would be let in. And finally, changing your password frequently will always aid in password attack mitigation. Now let's take a look at server-side attacks, which don't involve the user and specifically target the password stored on the server. From an attack standpoint, it is better to attack the server to gain the max benefit, but it is also more difficult. The main countermeasure to prevent server-side attacks is to utilize secure one-way hash functions. In this method, the user enters the ID and password. The system then applies the hash function to the password and computers. The hash to password is a stored value in the password file. If the two values match, then the user is authenticated. If not, the login will be rejected. An additional countermeasure that you can use for server-side attacks is to use a password salt. Some of you may be familiar with this type of approach because it has been used extensively in Unix system for quite some time. The idea here is to still use the hash password, but to store it with a password salt to compute the hash value. A password salt is a random number which is associated with every user. This number is used to compute the hash value with the password. This type of approach is a huge advantage and makes authentication much, much stronger. Take a look at the example diagram at the bottom of the slide. You will see the password foobar. When you add a salt to this password, you will see the output given 1AIJW. Additionally, hashing it or encrypting will yield the result in the yellow. In the following slides, we will go into further detail of how this works. Utilizing the password salt with a new password can be done by following these steps. The user selects or is assigned a password. The password is combined with a fixed length salt value, usually a pseudo-random or a random number. Both the password and salt are used in the hashing algorithm to produce a fixed length hash code. The hashed password is then stored with the plaintext copy of the salt in the password file. When a user logs in, the user provides an ID and a password. The O/S uses ID to index in the password file and retrieve the plain text of salt and the encrypted password. The salt and user supplied password are used as input to the encryption routine. If the result matches the stored value, the password is accepted.